All right, welcome everybody. We're going to go ahead and get started. Thank you for joining us and listening in on today's webinar. My name is Lindsay Lau. I'm the Director of Sales here at TAPCO, and I want to thank everybody for taking the time to join us from your home, your office, wherever COVID-approved environment you may be in. We had hoped to be meeting with all of you today in person, but obviously with the current situation, it just wasn't possible. That said, we've invested time to make this presentation as engaging and as informative as possible through the use of some great webinar technology that you're viewing on today. So we're going to include some poll questions throughout for the group, as well as plenty of time for questions that can really be submitted throughout. So we'll have time at the end, but if you hear a presenter say something and you have a question that comes to mind, we'll take those questions as we can. If it's something that we're going to cover in a minute, we might just say, hey, hold on, we'll answer that in a second. So yeah, we're going to try to be as fun as we can this morning. So I really hope you enjoy it. I want to get the ball rolling because we have a lot of content. We obviously want to leave some time for questions, but today we're presenting some fresh content and information about the wrong way driving issue today, as well as the TAPCO wrong way systems that Terrell's in the final stages of approving. We're expecting our system to be listed any day now, and we'll certainly make sure that we communicate it when that listing is finalized. Just a little housekeeping before we get started. I mentioned that there would be plenty of time for questions. So if you do have a question during the presentation, just type it into the chat box on the right-hand side of your Demio control panel there. And again, I'll be sure to bring them up during the presentation where appropriate. And again, we have time for questions at the end if needed. Okay, so let's jump in. Let me just pop into our agenda for today. So this is our agenda today. I'm going to first kind of talk a little bit about TAPCO. I'm looking at the screen and the attendees on the screen. I'm seeing some familiar faces, but there might be some folks who aren't as familiar with TAPCO. So I'll go ahead and give a quick overview before we jump into the technical wrong way systems as well as the wrong way issue. But before we do that, I want to start out with our first poll question. So Hannah, if you have a poll question you want to pose to the group here. So again, have you worked with TAPCO in the past? If you could let us know, that'd be great. I'll spend more or less time on the first couple slides here based on what you guys say. Okay. Half and half. Awesome. All right, cool. So it's good to see so many of you have worked with us. That's awesome. So you might be familiar with some of what we do, but I'll give you a quick overview of everything. This is our mission. So I'm not going to read it to you, but our mission really does define who we are. When you think about TAPCO or when you become familiar with our company, what you're going to see is safety. So that's what our focus is, whether it's from new product development to service. It's safety in the transportation industry. So that's what our systems are focused around. If you don't know, TAPCO is an acronym for Traffic and Parking Control Company. We've actually been around for over 60 years, and we're family owned. So we've been on the roads, we say, longer than the DOT, right here in Milwaukee, Wisconsin. We manufacture, sell, and service patented TAPCO-made products and solutions. That's what makes us unique when you look at other companies in the industry, is that not only are we making and selling these products, but on the back end, we provide the field service to make sure that they're installed correctly and maintained correctly for years to come. We're experts in solar powered traffic safety solutions, so that's been a real area of growth for us and an area that our customers have enjoyed, the fact that we were able to be very precise and reliable about the way that we power our systems with solar power. That's been great for our Florida customers, obviously, plenty of solar down there. And our service and distribution network is nationwide. So as I mentioned, we're sitting here talking to you from Milwaukee, Wisconsin, but we have we provide service and have a wonderful network of distributors nationwide. Our great relationship with Brett McCain and Universal Signs down in Florida. There are boots on the ground out of Fort Pierce, Florida, and are there maintaining contractor relationships with all of you and making sure that we are as attentive as possible. So I know Brett McCain and Sean Stone are on the call today. Thanks, you guys. And so we work hand in hand down in the state of Florida together. I'm going to give you a little bit of our secret sauce here. And this is what, again, what I think people need to know if they're looking at doing business with TAPCO. First and foremost is our service. The thing I'm going to highlight here that I haven't really said is the fact that it's a turnkey experience. So what you're going to get with TAPCO is the design on the front end. So if you're a design firm on the phone, or if you're someone with the Florida DOT or with your municipality, call us on the front end. We're great at helping you plan, taking a look at sites, and offering some value-added services to help make sure that what you design and specified is gonna work the way you want it to. And then we take that design and we actually make it here in Milwaukee, Wisconsin. And then on the back end, as I mentioned, we'll be there for installation support and post-sale service to help you maintain that system beyond the warranty and for years to come. Expertise is something that we've spent 6 years building, and specifically with regards to wrong way, I have to say, we are really the first ones out there doing wrong way detection systems. We've been doing it for 10 years. We've got a lot of lessons learned, and we've got a great system now, very reliable. I've enjoyed working with Terrell to make it even better. Outside of just wrong way, you can see we've got some logos on the bottom of this screen: ATSA, IMSA, ITE, NCU, TCD. We've got TAPCO staff members sitting on boards at all of these organizations. So it's not just to advance our own agenda. It's really to understand and keep our finger on the pulse of what's going on in the industry, and make sure our new product development team is fed with innovative ideas that are actually helping the transportation industry. As I mentioned, we're in the business of safety, so quality is it literally is, as the slide states, an obsession here. Our responsibility is to serve our communities and the communities that you serve. And so if the systems don't go out and they aren't quality, and we don't leave making sure that we know that they're going to operate the way that they've been designed, it's certainly a problem. So we are very obsessed with quality here at TAPCO. And then finally, innovation. So we have invested a lot more in our new product development and innovation in the last few years. Our wrong way detection system that's going to be listed on the Florida APL is a great example of that. But we've also looked at not only systems, but components of our systems, and helping to make them more reliable, longer lasting, more serviceable. And so we're really proud of that. So that's kind of all I have, quick in a nutshell. That's TAPCO. I am going to turn it over to our resident expert here at TAPCO, Nick Schmidling. Nick is our product manager for our wrong way driving solutions. And so he's going to give you a quick overview of the issue and then get into the wrong way driving systems here at TAPCO. Thanks, Nick.
Awesome. Thank you, Lindsay. Like Lindsay said, Nick Schmidling here, product manager of our wrong way driving solutions. But before I get started, Hannah, it looks like we have a poll question that we'd like to ask our attendees to answer. So if you could all do that quickly. What are you most interested to learn about with our wrong way alert system? Data collection, system accuracy. Okay. Awesome. Well, we'll definitely touch on a lot of these topics as I go through the technical side of our system here. So with no further ado, let's get started. So wrong way driving, the problem as we know it. In 2018, there has been 1,673 fatalities with wrong way driving incidents. It's been the largest number of wrong way driving fatalities since 2010. And as you can see there with our trend line, it's an upward trend. On the left there is what's happening at the national level. And then on the right there is unfortunately what is happening at a local level within the state of Florida. So year over year, the number of wrong way fatalities has grown, unfortunately. And currently, wrong way driving fatalities account for about 4.5% of all traffic fatalities. Obviously, a very severe nature of incident. So traditional wrong way driving preventive measures are your static signage, right? It's what we've all seen in many states across the nation is a starting point for their countermeasure remediation, right? Larger signs, 48-inch signs, double stacking signs, incorporating different forms of language, do not enter and wrong way. But unfortunately, what we've seen time and time again is that static signs just aren't producing the results that are needed with wrong way driving. So An unfortunate example of this was Arkansas recently. There's a case study. They invested $3 million across their state in static signage. And after about a year of those signs being in the field, they actually saw an 80% increase in the number of wrong way fatalities. So not saying that these are producing events, but obviously these static signage and these traditional measures are not working as they are intended. So let's talk about the TAPCO system and why TAPCO. TAPCO, as Lindsay mentioned, we've been a wrong way leader in this application for about a decade now. So we have over 750 installations across the US and Canada. We utilize exclusive detection sensoring that I'll touch on as we get a little bit further along here. And we believe in this new superior and accurate and precise form of detection within this wrong way space. What it does is it refines the data. As you see there in your poll question, data is something that is very important. So the more accurate, the more precise that data will be. We'll touch on BlinkLink and what that means and how we're translating those local detections to the authorities or to the end user in the form of alerts. And we have the ability to integrate with numerous communication network architectures. So this is something that is new, and we'll definitely touch on our new enhanced capabilities with different forms of network architecture build-outs. And the way of the future, as we continue to hear, it's just a matter of when, is connected and autonomous vehicles. So we are the only manufacturer today that offers connected vehicle capabilities within the wrong way space. And I guess not necessarily a fun fact, but a fact nonetheless is that across all of our systems in 2019, we have 387 confirmed wrong way detections. So think about that, 387 events where we're providing insight, data, and the ability for our end users to go after these offenders and to minimize what we know that these events will potentially cause, which is unfortunately a fatality. So what is the TAPCO system? The TAPCO system is predicated on utilizing LED enhancement. And the reason being is that 71% of these wrong way events occur at night, between 6 p.m. and 6 a.m. So this LED enhancement in the form of a sign, a red RB, or a beacon really replaces that static signage and or enhances the visibility of that signage, right? So taking your standard sign and commanding that driver awareness with those very bright red LEDs. So a study done by TTI has shown and proven that this LED enhancement, depending on the configuration, is proven to reduce wrong way events by 38%. So all of our systems are predicated on enhancing that point of communication, which is most oftentimes that signage. So looking at a standard detection pole, you can see here on the right, starting from the top, at the top of our pole, we have our sensor. It's going to either be thermal or radar. Next, we have our power, which is going to either be solar power or AC, depending on the location and the capabilities at that site. Next, on the pole here, we have number 3, which is the white LED illuminator. And this illuminator is to support the high-speed, high-definition camera, item number 4 there. So when these vehicles are detected, they're triggering the cameras to turn on, to go back in the buffer and capture imagery of these vehicles. In order to optimize that imagery, we have white LED enhancement so that you can very clearly see this distinction, the color, make, and model of that vehicle. As I alluded to, number 5 here is that LED enhanced warning device of choice. And then number 6 is the cabinet, right? The cabinet that's containing either that cellular modem or that fiber connection to translate that local detection and communication from the local site out to that endpoint of usage with the customers.
Nick, I'll stop you really quickly. I had a couple of questions. One, I think the one was regarding SunGuide connectivity, which I believe we'll get to a couple points later in the conversation. But we also had a question from Adam regarding any work that we've done with LiDAR sensors. We know we've heard a little bit about that. Did you want to address our testing and work with LiDAR?
Yes, so LiDAR is something that is definitely popped up as in the last couple of years as we're talking about autonomous vehicles and connected vehicles. But what we've seen in our study and in our analysis is that, for one, the detection technology is very expensive, both in terms of the cost of the sensor, but also in terms of the power consumption. So a lot of these locations on these ramps don't have AC power nearby. And unfortunately, with the LiDAR sensors, there's such a high power consumption that it wouldn't be conducive to allowing for a solar configuration. So LiDAR is definitely being used in autonomous vehicles on the actual vehicle itself. But in our analysis and our comparison of what we believe is the best detection technology out there, we just don't see it as being usable in our current application at this time, at least with the current capabilities that have been presented in the market.
Is that, and what we've found over 10 years of working with them is that you can't just use any sensor. It really has to be designed for wrong way. So the thermal sensors that we use today actually have a wrong way logarithm built into them, and that's one of the reasons why they're so effective. LiDAR just doesn't have that, or we haven't found one that has it today.
Awesome. Thank you, Lindsay. So to further elaborate on our detection portfolio, I'd like to show you our tiered solution. And I'll talk about this coming up here a little bit further about right-sizing the sensor to your needs. But looking at the good, better, best notion of our detection portfolio. So on the left there is just an LED enhanced sign, right, with the solar package. It's enhanced more than a static signage, but it's either flashing 24/7 or what we call dusk to dawn, so essentially at nighttime. Really, the drawback with this is, yes, it's a level up from a static sign, but there's really no offender interaction. So there's nothing that is triggering that sign to flash when a vehicle is going up that ramp in the wrong direction, which that helps the driver understand that it's them that is doing the incorrect action or that has the poor behavior. So you miss out on that opportunity. So it also is not connected to BlinkLink, and I'll touch on BlinkLink coming up here and that and all those different features and benefits. But really, you miss out on the event details. You don't know if the system's necessarily operating because you don't have that BlinkLink connection. You're not capturing data, and you really don't have that opportunity to develop a lessons learned analysis with that data. So next is our better tier. This is our middle of the portfolio tier here, and this is a radar detection system. This is what we identify here at TAPCO as the entry-level activated wrong-way solution. So it's activated with that wrong-way behavior, and so it offers that interaction with the driver and the system to trigger those LED warning devices. And it also is connected to BlinkLink. So with those cameras, you're capturing the color, the make, the model. You get the directional overlay from those camera images, and I'll show you what that means coming up here. You have the ability to see that the system is online and operating. We understand that you guys want to know that the system is flashing, the system is working, it's been triggered and activated. And then you understand where these events are occurring. So you can start to create a statewide or agency-wide heat map and location of events, time of day. But really the drawback here with radar detection is that with complex ramp geometries or locations where heavy rainfall may occur, the system can be conducive to false detections, and I'll show you a little bit more about what I mean by complex ramp geometries. And then our top tier is our best, and this is our thermal detection, utilizing our thermal detection that you can see there on the right. So this is our premium tiered offering. This is the tier that offers you a 90, sometimes 95% reduction in false detections by going to the thermal detection. So we understand that certain agencies are allocating additional resources to the routing and the intercept of these offenders. So it is ideal to utilize the thermal detection for these interconnected traffic safety operations. So you guys want to know that if you're about to send out the authorities, or if you're going to allocate resources or send out communication on a DMS board upstream, you want to know that you actually have a wrong way event and not a false detection. So once again, with the thermal detection tier, our best offering, you get all the BlinkLink connected features. And really, if you are interested in seeking a connected vehicle application, we really highly recommend utilizing the thermal detection, because you are going to be pushing out communication in vehicle alerts to those wrong way and right way drivers that are nearby that system. We want to make sure that there's an actual wrong way event that's occurring before you push out communication. Next, we're talking through the communication portfolio. So this is what I was alluding to earlier. We have new capabilities this year, and I'm really excited to share this with you all. But Option one on the left there is kind of our traditional TAPCO system. So for those of you who have done business with TAPCO in the past, you probably understand what I'm talking about here with our traditional option one scenario, which is TAPCO provides a cellular modem. It's a 4G modem. It's network agnostic. So whether it be Verizon, AT&T, T-Mobile, Sprint, whatever's best in that area, that cellular modem is agnostic. When you purchase the system, 2 years of BlinkLink is included with that system purchase. And then after the 2 years, there's an annual recurring BlinkLink cost per system for each year thereafter. Because it is connected to BlinkLink, we have the opportunity to access the system and to support any troubleshooting and service needs that may occur. And we're very excited about our event latency. We understand that each second matters in these scenarios. You have vehicles that are going anywhere from 30 to 60 miles an hour in the wrong direction. Every second counts. So we take pride in our event latency, and we'll show you what that means coming up here. And with this system, option one here, we're also able to offer an API into your agency or to the state ATMS. Option two is the new communication tiered offering that we're now able to provide to you. So what this uses is what we call the advanced communication controller there. You can see it pictured right below the LED enhanced sign. And what this does is it allows us to connect our typical wrong way system to your fiber network or your agency's cellular provided modem. So we understand that fiber is a growing trend across the nation. As these ramps are being developed, AC and fiber are being brought out to these ramp sides. We now can connect our system to fiber and provide that same BlinkLink user experience. Or on the inverse, we understand that sometimes different districts and agencies have contracts with cellular providers and actually would prefer to use their own cellular modem of choice. We can incorporate that cellular modem and still give you the BlinkLink features. And this is all done through VPN connections. So it's secure and it's reliable because we are not coming back to our server necessarily, and we're able to provide that same BlinkLink user experience. So very excited about this new capability. And then the third, option three here, which is also new, is the direct to ATMS integration. Once again, it utilizes the advanced communication controller, and what it does is it directly communicates that local site to the ATMS software platform. So for this instance, high-speed fiber network is necessary, and because there's a direct connect to ATMS, we aren't able to utilize the BlinkLink features. We're not able to offer it because it does not come back to our BlinkLink software. So because there's no BlinkLink interaction, just know that we have limited access to really dive into that system and support troubleshooting and servicing needs. It makes it more complex when our system isn't able to offer the BlinkLink connection. And because it's a direct connect to the ATMS, API is, I want to say it's not compatible, it's just not applicable. It's directly communicating to your system. So as we talk about our systems, we want to help you understand kind of the decision process that goes into identifying what you need in your given locations, right? So as we work with you to design the optimal system, we're going to ask you for insight, and this is great for those design firms to think about, is, you know, what does the local power look like? Do you have AC locally, or are we going to be talking about solar? As I just talked you through, the network of choice. So is it the TAPCO network or is it agency network? Now talking about the system itself, let's talk about the alert details. So when a detection occurs, what do you want to see? Where do you want those cameras to be pointed on that ramp? Do you want to see downstream? Do you want to see upstream? Do you want to see near the gore, which is where the ramp connects to the main line? And then also, when you get those alerts, what do you want as a low priority alert or a high priority alert? So oftentimes sign activation can be presented in the form of a low priority alert. And then if the vehicle continues up the ramp in the wrong direction, that's when we would send out that high priority alert that, hey, you have a vehicle that is not stopping. We also are going to talk with you about your response protocol. Who are you allocating as a response to these system inputs? Do you plan to go after these vehicles? Do you plan to connect to a DMS board? What other systems are you connecting mainline CCTVs to these systems? We want to talk through that and offer the best configuration for your needs. We want to right size the detection. So what does the ramp geometry look like? And that's coming up here on the next slide. What are you going to do with your system? Is this going to be just a local detection and deterrent, or are you going to actually have, we call a super user, and continuous oversight, someone at the TMC that is continuously monitoring these system inputs? We want to understand, because that can help identify the proper sensor of choice. When configuring the location of the system, we want to minimize the vehicle speeds, because the faster that they get up to speed, the more opportunity there is for a fatal collision. So that is why we have a predetermined and logically placed system location near the base of that ramp. We want to maximize the number of warning device flashes. So we're going to use standard speeds, anywhere from testing from 5 miles an hour up to 35 miles per hour, and optimize the number of flashes so you can really maximize that opportunity for the vehicle to identify that they are inducing an incorrect behavior. And like I said, the location is key. And then, as we are all interested in, is what is that initial project budget upfront? What's that initial investment of the system look like? What do you have allocated for this project? And we can configure and tailor depending on the different tiers that we offer. But also considering who's going to control and maintain these systems after the system is purchased, right? There's a cost for maintenance. Different sensors and different configurations are conducive to either more or less service requirements. So we want to identify that up front. That way we can optimize the ROI of the system over 10, 20-year lifespan, rather than just the initial upfront cost. So a typical configuration is like you see pictured here. It's a 3-zone configuration. Zone 1 is what we call the alert activation zone. This is where the vehicle triggers the system after it's been detected, and it triggers all the alerts that are on that location to flash in sequence. Obviously, the goal here is to stop and have that driver self-correct, and this zone 2 here is what we call the correction zone. This is just a theoretical zone. It's the spacing between the poles on the system to allow for the opportunity for a driver to safely self-correct. We wouldn't want to do this up near the main line. I continue to elaborate on that. This is why we have specific system location choices near the base and foot of that ramp. And then there's the confirmation zone, which is another detection point with a rear-facing sensor, which will detect that a vehicle has continued up the roadway, up the ramp in the wrong direction. And that is when the high priority alert, hence the red there, is going to be sent to the TMC. So like I mentioned, we can use either radar or thermal. Radar can be used for simple ramp configurations, no nearby on-ramps or minimal traffic queuing or limited precipitation. It's a low-power, solar-friendly radar. It can detect up to about 300 feet, and you're going to get about 2 to 4 lanes max coverage with radar sensor capabilities. So right here is where I want to show you what I mean by complex ramp geometry. On the left here is what we would consider simple, right? It's just a traditional ramp. There's no nearby yard with maintenance vehicle traffic. There's no nearby on-ramp. And this is, once again, assuming not a high precipitation region. On the right here is what we identify as a complex ramp geometry. This is where thermal needs to be involved, where you have that nearby on-ramp. So regardless of however we can configure that radar, we've done this for many years, we've identified that with these nearby on-ramps, these cloverleaf designs, it's very conducive to producing a false detection. This vehicle that's going up this ramp here on the right is actually going in the proper direction, and that's what can be, that's what produces sometimes your false detection. So in complex ramp geometries, this is when we're going to recommend to you, hey, we really need to consider thermal detection. So what is thermal? Thermal is essentially, our thermal sensors are taking an image of heat and converting it into a viewable image that the human eye can see. So traditionally and historically, humans cannot see heat. Maybe in summer on a really hot day, or when you're grilling out and back, you can see those heat waves kind of simmering on the grill or on that asphalt. But traditionally, humans can't see heat. So what the thermal sensor is doing is it's taking that heat input and converting it to a viewable image, and you can see that here pictured along the bottom. So our partner for thermal sensing is FLIR. and we are exclusive distributor of the FLIR thermal detection in the US. So what FLIR allows us to offer is 24/7 fast, reliable, and accurate detection. I mentioned that 95% reduction in false detections. It's a precise zone configured detection, and I'll show you some video of how that looks. Because we're looking for heat and we're not visually looking at a vehicle, we can see at night and in complete darkness. So sometimes these under the influence drivers forget to turn on their headlights. A visual detector would not see that vehicle, right? We're looking for heat, so it doesn't matter to the thermal sensors. We can see through shadows and sun glare. You can see that picture there on the bottom. And it's favorable in all weather conditions, including fog, rain, and snow. So precipitation is something that really negatively impacts radar detection. It's easy to set up, and as I mentioned, we are really looking at this as a lifetime investment, you know, and a 10, 20-year investment. What does the maintenance of that system look like over the long haul, not just initial upfront cost?
Starting the from Sherry asking, do you have the capability of configuring the distance that the radar detects? You indicated that it can go a distance of 300 feet. What if you only want to detect within 100 feet? Is that something you can configure? And I believe this is the radar specific, but might be a good time to talk about the FDOT detection specification and the difference. Are you comfortable answering that, or do you want me to have Jamie answer that?
Jamie can answer that.
Okay.
So yes, we can configure to a distance less than 300 feet.
We have the ability to tilt the camera, tilt the radar down and pivot it left and right as needed.
That, so what Jamie said, hopefully you could hear what Jamie said. He said that it's basically by angling the radar down is how that's the way you can configure. The Florida DOT, the TARL specification with regards to wrong way detection, specifically the detection, does state that you have to have the availability for configurable zones on detection. So you should be noted that that the thermal detection sensor that we're talking about from FLIR has that ability. So the FLIR TrafiSense that you see on the screen right now would be an approved form of wrong way detection through the Florida DOT. So some of you might have been familiar with our dual radar detection systems, or there are wrong way detection systems on the market that have 2 radars for detection. I'll talk more about this at the end, but that would not be a system that would be able to be listed on the Florida APL because the radar doesn't have the ability to program configurable zones. There's another question here. Can the system work with Wavetronics radars? So again, Wavetronics is a side fire radar. Nick, you could probably answer this as well, but can it work? Yes, our systems can work with really any method of detection. However, to my knowledge, Wavetronics is not an approved form of detection in Florida. And also the side fire radar presents a lot of limitations and false detections because of the nature of how it detects. It's not detecting actually wrong way driving. It's just simply a radar. So Nick, I don't know if you wanted to elaborate on Wavetronics specifically.
I can show you what happens with side fire radar detection coming up here and some of the results that occur with that type of installation. So I can touch on that, yes.
Perfect. Perfect. Thanks. Great
Awesome.
questions, everybody.
So at TAPCO, we utilize 2 forms of thermal sensors. On the left is what we use for a wrong way vehicle. It's the TrafiSense. But just know that we also use thermal detection for pedestrian crosswalks. So obviously, we're in the midst of a national and global pandemic where pushing and touching items is less than ideal. So we're talking about passive detection and passive activation. Definitely use that on the crosswalk side as well for activating crosswalk illumination and whatnot. But for here today, we're talking about the TrafiSense and its incorporation into our wrong way systems. This video I won't play, but we're going to be sending out the presentation hereafter, and you'll be able to play the video. It's also on our YouTube. It's on our website. It's a great summary video of our wrong way system. So I ask you to definitely take a look at this and watch this. It's about a 2-minute video, so it's brief. Gives you a good overview of our technology and capabilities. So looking at the different configurations, this is what Lindsay alluded to with Terrell's APL listing. And that is that the APL specifically asks that you can view and configure a zone, but ultimately be able to view the point of detection. So this is what it looks like when you're configuring the thermal sensor on the ramp per each lane here. So each one of these boxes with the associated triangle at the front there is viewing a specific lane, and that's your point of detection, and you can actually see this with the sensor. So the question about Wavetronics, I'll allude here that recently Colorado did a study on wrong way detection capabilities, different sensors. They looked at TAPCO, they looked at some other providers there, and one of the providers offers that same side-fire radar detection technology. And you can see here the false detections that occurred with the different systems. And this radar side-fire detection produced 462 false calls over their study, where the TAPCO system only produced 3, right? So when you look at the reliability of our thermal sensors, it's reliable day and night, minimal falses here, in both daytime, nighttime. Like I mentioned before, unaffected by weather. Colorado, we're talking about snow. Florida, we're talking about rain. That radar sees that heavy rainfall as moving objects, and that's what triggers that false detection. And then superior system latency. So talking about the speed of communication from that local site to the end user, TAPCO has been identified as having the industry-leading system latency. So communicating the quickest possible, from the time of detection out to the TMC and that end user. So as Lindsay mentioned, we've been doing this for a decade now, and we've tried all the detection sensors out there, from visual to radar to laser. And what we've learned is that really thermal is the best across the board. It allows you to have a passive detection. It's not invasive like loops are. It's not affected by weather. I just showed you that. You can monitor multiple lanes, up to 6 lanes with a thermal sensor, out to about 300 feet. Radar, I've mentioned that it has issues in heavy rainfall, and visual has issues with fog, rain, snow, and wind, by no surprise there. So overall, looking at all the attributes of what a good sensor looks like, thermal, we believe that thermal is really the best sensor out there for our users. Looks like we have a question from Adam. How many sensors, thermal, radar, were used in the CDOT false call evaluation? So for TAPCO, we utilize what we do on every system, which is a forward-facing sensor and a rear-facing sensor. So for Colorado, we utilize a forward-facing thermal sensor and a rear-facing thermal sensor. Good question. Sherry asks, have you compared it against camera feeds that use AI technology to detect pixel changes within the defined areas? AI is something that we have not incorporated into our systems yet, but it is something that we are looking at for video and visual analytics. So we use those CCTV cameras. So we are looking at what AI may mean for our systems in the future. Good question. So here is some videos that you guys will be able to play offline of different events occurring, vehicles coming up the ramp in the wrong direction, and you'll see how that triggers the system. You'll see the heat profile of that vehicle and how that sensor is looking at the heat of the vehicle and not the visual elements of that vehicle. So this is a big point that I want to touch on, and it's regarded to our software. So the software is really where we're compiling that imagery and that event communication and sending it out to the end user. It's a cloud-based software, and it's BlinkLink. And out of all the manufacturers, BlinkLink, TAPCO's BlinkLink is the only one that has that SunGuide integration. So we've had SunGuide integration now for a couple of years. I alluded to earlier on the directional overlay, and you can see what that means here on the right. So each image that comes across, and when the video comes across, you'll see the directional overlay of that image capture when an event occurs. And we're able to directly integrate this imagery into the ATMS software for streamlined communication. As I mentioned before, we have an optional API if you're looking to connect all of your systems, your DMS boards, your CCTVs, et cetera, to our BlinkLink inputs. The imagery is 1080p high definition. We are now offering events video. It's a recent feature that we're adding to the mix. So we understand that users don't necessarily just want to see pictures, but they also want to watch a video of the local event and analyze it maybe at a later date. And then a big point here is the system health and diagnostics for BlinkLink. You can see down below that we offer diagnostics both with our thermal sensors and with our visual cameras. And what that is actually doing is pinging the key points of the system and making sure that there is communication so that you have reassurance that the system is upline and operating as intended. So a typical event occurs where you have your initial detection, you have your alert that's presented to the end user within BlinkLink, and then from there with a human confirmation of, yes, this is a true event, you can connect your other systems, your other components, your DMS boards, you can send out the authorities, and you can understand what is happening at that local site. We have some images here from BlinkLink, and you'll be able to play this offline, seeing the different types of detection that we've captured over the years, from motorcycles to rainy days to nighttime. It's a great coverage of the BlinkLink capabilities. This is some data directly from our BlinkLink connected systems. Right now, TAPCO has 100 active and operating systems in the state of Florida. And over those systems, over the last 2.5 years, since 2018, we've documented 448 wrong way events from the Florida-based systems. And I guess, you know, the good news here is, yes, at a national level, there's an issue with wrong way driving, and Florida still is seeing a growth in wrong way driving. But you can see that with these systems, we're seeing a decline in the number of events, which basically is showing that the systems are working and they're deterring events, and they're optimizing the opportunity for self-corrections to occur. Looks like we have a question from Sherry. Have you considered or make an option for the use? Use of streaming image capture with motion tracking. Some of the challenges we have with actual wrong way drivers is image captures will identify the vehicle, but sometimes the picture captures the driver pausing, but we don't know what they end up doing because we don't have a camera that has a view into the ramp. So that is why we're offering video, and that's why we also offer system enhancements with additional cameras to capture more viewpoints on that ramp. It looks like we have another question from Jay, but I have to keep moving here. So if we have some time at the end, I'll take your question at the end. So this is a heat map of those BlinkLink wrong way events and where they're being derived from. So the bigger the circle, the more the larger number of events and the severity of those events in that given location. Our system enhancements, like I mentioned earlier, you can optimize and improve your system, our standard system with the connected vehicle technology, those ramp overview cameras that I just mentioned, which gives you a little bit more insight with additional vantage points. We offer license plate recognition, in-road warning lights at the base of the ramp that are unidirectional, so only pointing towards the wrong way driver. And then we do offer dynamic message boards. This is just showing you how connected vehicle works. So we are RSU agnostic, so we can work with any of the RSU cellular or DSRC providers out there. And what the system is doing is it's detecting that wrong way vehicle and then transmitting that message into those local vehicles that are connected. So you can see here, this is actually an installation in Florida with the right way driver message and the wrong way driver message. And it knows to send the proper message accordingly with how that RSU is configured. And then lastly for me, TAPCO service solutions. So with each TAPCO system, we provide on-site commissioning turn-on assistance, and it's led by our expert ITS certified technicians. We also offer preventive maintenance contracts, so 1 to 5 year contracts that are available based on your needs and your budget. So there's some different criteria there for what we can offer, and you can see that there. But what is a nice feature of these preventive maintenance contracts is it extends the system warranty an additional year past the last preventive maintenance. So 5 year contract, you're going to get 6 years of warranty. So we're very excited to offer that local preventive maintenance contract if it's desired. So with that, I will turn it over to Lindsay to talk specifically about Florida's state APL and how it pertains to our wrong way systems. Thank you, Lindsay.
Nice job. Oh, Nick, do you want to answer in the chat, just because we're running a little bit short on time? And Sherry had a great question about adding in road warning lights. What I'll do is I'm going to run through, these are just a couple of slides. It should take me less than 10 minutes to talk about the Terrell approved wrong way solutions. But I do want to say that we'll stay on for questions as long as we need to, but we might go a little bit over 10 o'clock with the questions. So we will keep moving forward here. So what Terrell decided to do is list two types of wrong way solutions for TAPCO. They're going to list a solar powered system configuration and an AC powered system configuration. Based on some of the stuff that Nick just talked about with regards to power, power can govern the components that go into a system based on activations and all types of things, all sorts of things. So this is a great way. Oh, let me just make sure. Sorry, I'm getting some feedback that maybe I'm not hearing me very well. Okay, let me know, guys. Oh, thanks, Adam. I sound a little bit muffled. I think what I might do is try it without my headphones. Any better? As I mentioned, there's two different systems that are going to be listed on the Florida APL for TAPCO. One is a solar powered system. One is an AC powered system. Thanks for the feedback, everybody. What I'm going to go through are the basic system configurations as noted by the FDOT specification. So we have a system that's going to be on the APL that is going to meet the spec exactly. Now, we have additional enhancements that we've worked with Terrell on that can be offered, and then we also have ETO enhancements that can be approved through Terrell after the fact. But I just want to make sure I'm very clear about exactly what is listed on the APL. So the first is a solar system configuration. So you may or may not know that while we were testing, Terrell had introduced the guideline that they'd like 10 days of autonomy. So I assume everybody knows what autonomy is, but that just means that the system can operate without sun or without charging those batteries within the cabinet for a period of 10 days. This presented some issues for us because it is a long time and there's a lot of items pulling power off of that pole, but we've got a great solution that can last, frankly, more than 10 days. So that's what we'll show you in a second here. It's generally a 2 to 4 pole system based on your ramp design. Generally what we're seeing is radar on the incoming detection and then the FLIR thermal radar on the outgoing confirmation. So the confirmation zone is going to be that FLIR configurable zone radar. You can flip-flop those, and you can use 2 thermal cameras if you'd like, but at least one of the cameras does have to be configurable. We've got a camera on the back of the system, so facing the confirmation zone, that's going to record both video and images, Sherry. So we have the capability to do both, and then we can offer an illuminator above that camera as well if you don't have proper lighting available, just to make sure that that image is crisp, crystal clear. It's a full color image. People really like the imagery on the video and on the images that we send. We can accommodate either a fiber or a modem connection for the communication of alerts. If you have fiber there, that's great. It's the fastest form of delivering those alerts, but modem, as Nick mentioned, our latency is best in the industry, so we can definitely and do quite a few modems. We're going to use a 334 ITS field cabinet that's got to be ground mounted outside the clear zone to hold the batteries and the system control panels. So this is new. If you're a current wrong way detection customer in Florida, you might have that that control panel detection pole cabinet mounted on the pole. We're not going to do that per the Terrell specification. So I'll show you in a second. We have to mount it outside the clear zone on a concrete pad and then conduit back and trench back to give power to that detection pole. We've got pole mounted solar panels, again, that will be located near the 334 detection cabinet remotely. And then we do have an option for a customer supplied cabinet. So if you've got a cabinet that's near fiber that you'd like to use, or you'd like to install the cabinet ahead of time, that's fine. We have insert panels that can be mounted to the rack inside the cabinet. If you'd like to do it, we are going to take up all the space in that cabinet, so you can't cram a bunch of stuff in there, but if you'd like to do that, we can offer that ability. So here's a look at the pole layout drawings. The systems, the solar and AC systems, you know, really at a glance look fairly similar, but you can see that the system's going to include an LED enhanced sign, radars, the antenna for the radio. Pretty self-explanatory here, so I'm going to move right along. And then this is just showing the ground-mounted cabinet as well as the remote-mounted solar poles. So the pole and the cabinet can be very close together. Should note that we use 12-gauge wire, 12-gauge cable for conduing the power back to the detection pole. If you want to go, we recommend being under 150 feet for that cable management and that 12-gauge cable to be effective. If you want to go beyond 150 feet from the detection pole, we certainly can do that. We're just going to adjust the wire gauge for you. Here's the 334 field cabinet. This is just going to show that image on the right is going to show how all the panels are mounted inside the cabinet on that rack, that insert panel that goes into the rack. And then we've got 3 shelves holding 8 batteries. So there's quite a few batteries in there, but that system's going to last without sun for more than 10 days. Now getting into the AC system configuration, a lot of the same as far as the poles, 2 to 4 pole system, radar incoming, flare outgoing. Now, because of the power draw and the thermal sensor, we'll lead a lot more with the radar flare or radar thermal combination on the solar, but AC obviously doesn't matter. So you can do a dual flare on AC. The AC system, I'll note, is less expensive too. Obviously the power from the solar panels and the battery, it makes that system a little bit more expensive. So there's room for doing a dual flare on these if you'd like. Camera still recording images. I should note too that specifically on the AC system, a lot of our customers really like the ability to put 2 cameras on the pole, which we do that a lot. So you're actually recording the event from the time that it initiates, so that car driving towards the detection pole, and then turning the back camera on as the car leaves and passes the pole into the confirmation zone. So you're capturing the entirety of that event. With 2 cameras on the pole versus the 1 that is a part of the Florida specification. So we can certainly do that. And again, we can use fiber or modem connections on the AC system as well. So here's a video image of the AC power system. This has got 2 thermal cameras on it. Just wanted to note that. And the main difference with between the cabinet is we're actually using TAPCO's 357 field cabinet. This is a more compact, frankly, a more cost-effective cabinet, but doesn't fit all the batteries you need for the solar system, so we couldn't use it for the solar system. But this cabinet is going to be mounted, ground mounted on a base. You can see here, remote mounted with holding all the system control panels. Again, we probably looking at within 275 feet of mounting just for the Ethernet cables. So you can mount as far as 275 feet away from that detection pole with these 357 ground mounted cabinets. I mentioned a couple of the enhancements, but just to reiterate, you can do thermal detection for the detection and the confirmation zone if you'd like. We can do the dual camera so that you're getting the visibility of the entire event. Again, a lot of our customers really like that because they want to view and analyze the behavior of the driver, what actually caused this event from the beginning. And then engineered to order systems. The main thing I'll say on this is that we do this a lot in Florida because, and with customers throughout the country, they want to use existing infrastructure potentially. They want to maybe look at other forms of detection. There's a lot of things you can do with these systems out on the road. I should mention mainline detection we can certainly do. We've talked a lot about ramps today, but mainline detection would be something that's available as well in an engineered to order system. So our applications engineers are here to help with that too. We talked, I'm not going to spend a lot of time on the software integration capabilities, but just to add to your question about BlinkLink and that integration into SunGuide, this details that well. I'll note one that the FDOT specification it currently does require the integration of software into SunGuide. Currently, TAPCO is the only one that's communicating wrong way alerts into SunGuide. So I know some systems may be approved without that. but that's something that's going to be required in the future. But again, we can give you just our BlinkLink software, which is the easiest method. We can, in System 2, use either fiber or agency cell or cell modem to actually communicate with SunGuide through an API and OpenVPN, and then also use BlinkLink. I think this is the best option because then you get the features of BlinkLink, system diagnostics, reporting. It's just a great interface for specifically wrong way detection, evaluation, and data collection. A lot of you guys talked about the fact that you are interested in data collection. BlinkLink is superior as far as wrong way detection software goes with regards to data collection. And then System 3 is just that direct connect through fiber right into SunGuide, bypassing BlinkLink and just receiving all of the communication alerts directly in the ATMS. Talked a little bit about warranty here. A lot of what's in Florida is a standard 5-year system warranty. So kind of move right along. There's a question, is BlinkLink free? Is that a smiley face after that? Just kidding. BlinkLink actually is included in the price of the system for 2 years. So it is a smiley face, I love it. So we do include 2 years of BlinkLink, and then past that, we'll give you a heads up that that contract is expired, and we'll work with you. I get it. A lot of agencies just want to host it. They want a one-time fee. They don't want to pay those reoccurring software fees. We've gone back and forth about it. So let us work with you. Generally, we'll do, we could do a 1-year subscription, a 3-year subscription. I've seen 5 to 10-year subscriptions. We just price them differently. So just let us know. But the answer is yes for 2 years, and then past that, it is a subscription fee. Want to talk just briefly about some of the services you're going to get with TAPCO, and we're working with TAPCO. And if you're a design firm or if you're somebody that's just contemplating a plan, give us a call. We can help you evaluate power. If you're looking at solar through our solar site survey tools, we work a lot with Brett McCain and Universal, send those guys out and work with you directly on solar capabilities. We'll do ramp site surveys. So if you've got kind of a complex ramp layout or anything that needs to be considered in the design phase, we can help you with that. We do a really nice job with fast turnaround submittal documentation. And again, our folks are out there on site with the contractor, whomever would get that award if it is going through a contractor, just to help them ensure that they're familiar with how to install the system, specifically aiming the detection, and then also helping with testing and turn-on support. Actually, one of our technicians is down at the Miami-Dade Expressway Authority last night doing a system turn-on and test. So we do that a lot, and we will be locating some of our technicians in the Florida area in the next 6 to 12 months because of the amount of systems that are going in Florida as well. So we'll prepare to support you. Project management obviously comes with this, and we're working with the contractors to make sure the project is managed, the equipment is there on time when it needs to be. And then post-sale, we can obviously provide tech support here at TAPCO, but we have some preventative maintenance capabilities. If you'd like to talk to us about that and just helping you do our recommended maintenance to extend the warranty of the system and also ensure that it continues to be operational. And as I mentioned, coming soon, a Florida service office. So that is everything that I have for all of you. I'll open. Let's see here. Are we doing another poll here, Hannah? Just went to poll, sorry. I'll open the floor up for questions, and I'm going to go back and kind of look to see if I missed any questions in the chat. Oh, got it. It is interesting. Yeah, projects are continuing as scheduled. That's good to know. That's what we're hearing across the country in a lot of respects. Not necessarily in the New England area, but outside of that, we're definitely seeing things move along, which is great. Did anybody have a question that they wanted me to address that may have been missed in the chat? I know Nick was going back and forth with some folks there, so that's totally fine. Anything else that I can address for you? Awesome. Well, good. We didn't go that far over, so that's good. Here's the contact information for everybody that's in this room, except for Jamie. Jamie answered a question earlier, our engineering manager, but he's certainly available. Please feel free to reach out to us. Presenters are here to answer any questions. The contact that you would contact would be Brian Everard. He's on the screen right here. I'm happy to answer questions. Nick's happy to answer questions. Brett McCain at Universal, if you've worked with Brett and Sean Stone, they are also available for contact. But if you want a specific TAPCO contact, please contact Brian Everard. So without further ado, just kind of wrapping up here, we'll be sending out all the relevant links to this presentation as well as a recording to this webinar within the next couple of days. So I kind of skip forward. You see there's some appendix items and some more information on this presentation that'll be included with the packet that we send out to all of you guys. You'll have that contact information as well to reach out to our TAPCO Florida contacts specifically, as well as today's presenters. So thank you again so much for all the awesome questions, the participation. We weren't sure how this was going to go. We would have, again, preferred to have our lunch and learn and our meeting down in Florida, which we still will do once we can. But this ended up being really great. So thanks all of you, and we look forward to working with you on future projects, and stay safe.